Hello, everybody. My name is Chen from Timeplus. Today, I'd like to introduce Proton, which is an open source project in Timeplus. It combines streaming query processing and historical analytics in one single binary. It is built on top of ClickHouse. Let's see how we build it. The fundamental problem Proton tries to resolve is when real-time data arrives at scale, how can we answer users' inquiry immediately at scale? We have observed lots of complex solutions out there in the industry. So for example, the user connect to different open source stack and build a complete solution that works, but it lots of complexity. So Proton tries to simplify all this kind of complexity and provide a lightweight, efficient solution. Internally, Proton basically need to build quite a lot of functionality from scratch. You can think of Proton is a combination of Flink, Kafka, and ClickHouse. For example, Proton's brand new implemented streaming query processing is on par Flink streaming query processing. Proton's internal stream store is on par Kafka, but for internal use only. Proton's historical data store and historical query processing is totally dedicated to ClickHouse OSS. So let's take a look at the storage layer. Storage layer is the fundamental enablement layer for efficient and powerful or performant query processing, both for streaming and historical analytics. In this diagram, on the left bottom side, you can see this a native log. It is a streaming store implementation in Proton. All of the ingested data get appended to native log first. And then in the meanwhile, there's a background thread taking the data from the streaming store native log and commit the data in batch to historical data store. So please note that when the data landed in native log, we can enable streaming query processing directly without any kind of waiting. Because background thread committing to the historical data store, we need to build different kind of reverted index, or secondary index, primary index. That will take some time. But for streaming query processing, we do not need that wait. So if users like to do pure query processing for historical data, they can do that like ClickHouse does. It is pretty straightforward. In a lot of scenarios, one query needs to travel through between these two data stores. So for example, if you have a streaming query, which needs backfill a lot of historical data, so Proton support that natively, and the user do not need to do any kind of special things. So because it has streaming store and historical data store in one single solution, so it enables this kind of backfill or travel through different data store natively and without any kind of data duplication and data loss, because internally is tracking the sequence number between these two data stores, and it connected with the sequence number. And also please note that the on-disk representation of the streaming store and the historical data store are pretty similar. And this kind of on-disk representation is very friendly and very efficient converting to in-memory representation as well. So when the query travels through this kind of data stores, and also you need to do unified query processing in memory, that minimizes a lot of data serialization, deserialization, and data conversion cost. This kind of cost is very, very significant in the open source stack. And this kind of data serialization, deserialization reduction also enable a lot of very, very efficient query processing in Proton. So Proton also supports query on stream directly. For example, if you have data in your Kafka, in your Red Panda topic, we can just create an Excel stream, pointing to the topic, and do query on the topic directly in a streaming way. This is exactly like what Flink does, but Proton provides a more compact and efficient solution compared to that. So Proton's storage is actually multi-model. In real life, not all streaming processing is append-only semantic. We have observed a lot of data mutability semantic in production. So this is why we provide a version key value stream and change log stream. So for different kind of user cases, combining this kind of storage stream and also with the incremental streaming query processing, that will tackle quite a lot of user cases very efficiently. So if you like to learn more about this kind of different streaming model, storage model, please check out our blog post. So everything is in Proton is streaming query by default. And we extend the SQL with a lot of streaming capabilities. So for example, you can subscribe a stream and the query result will push to the subscribers automatically when the emit time comes. And there's a lot of extension like streaming windowing and streaming to table joins, which is fundamentally streaming to join historic data and streaming to streaming join. And we also provide lots of extensibility, like using the JavaScript to provide the user-defined function, user-defined aggregation function. So except the pure historical table query processing like ClickHouse does, Proton as a streaming solution, it provides the most of the streaming functionality, like the popular streaming solution Flink provides, like streaming ETL, streaming join. Most importantly, I like to point out the two features which could be very powerful. One is substream, and the other is data revision processing. Substream fundamentally is we partition the Proton partition the big stream to small streams, substreams, and we check the state and aggregation state, and also watermark and emit strategy for each substream. That could be very useful and powerful for some of these user cases. Data revision processing combined with the storage model, like version KV and changelog KV stream, that a changelog stream, that will provide a more efficient and cost-effective solution to the end user. And mostly importantly, we have a brand new materials view implementation. The superpower of materials view is backed by this functionality above. It's a totally different implementation than the ClickHouse materials view, which is in just-time behavior. Materials view is basically incrementally maintain the state, and the materials the final result or intermediate result to the local stream or external storage. So as mentioned at the beginning, Proton is an open source project. You can check out Proton in GitHub repo. And mostly importantly, we are contributing back all the functionality to ClickHouse open source. If you like to keep monitoring the latest progress, please check out the ClickHouse issue and the corresponding pull request. Lastly, I'd like to do a quick demo. Streaming aggregating 260 million unique IP prefix with very small amount of memory with our enhancement for Proton. Here I have a query and I randomly generate 1 billion event and for the random generated IP address, and I'd like to calculate the IP prefix, which is the highest 28 bits, which is around 216 million unique IP prefix. And I also calculate the shuffle key, which is the highest 8-bit, and we do the shuffle by the shuffle key group by IP prefix and calculate the count for each of the IP prefix. The shuffle by is basically an enhancement in Proton, which reduces the memory utilization a lot. Let's see how everything works. So it keeps running, and right now it's 10 gigabyte memory utilization. So it's half billion already done. Right now it's 14 gigabyte is already done 1 billion, and the total unique data set is basically 260 million unique IP prefix keys. So if you like to dig into a little bit about the shuffle by implementation, this is the internal execution plan. Basically, you shuffle the data and two different threads, each of the thread processing partial of the key sets, and we have a compact hash table implementation like ClickHouse provides. That's bring the total memory utilization very low. So we will unveil all the technical details later in a blog if you are interested in this stuff. So this is pretty much what I have. And if you like to learn more about Proton, this is our resources you may like to check out. That could be very useful. And thank you so much. That's all.